Hi all, good morning to everyone. Have you all gone through the last session material and video? Have any doubts in that? Vigneshwaran, Harini, Shivabalan, do you have any doubts?
No doubt,
No,
sir.
sir.
No, sir.
Okay. In this session, we focus on control statements. Control statements. We have seen the general structure of the C program, constants, variables, operators, expressions, and we have gone through some of the simple problems. Next, we move on to the topic control statements. As a term control, right, which indicates that something needs to be controlled within the program. So, based on the logic of the program, we need to devise the control statements. There are two kinds of control statements. One is the unconditional control statements. Unconditional control statements. Second one, conditional control statements. Conditional control statements. These are the building blocks in a C program. So whatever is a C program, we can use these unconditional as well as conditional control statements to construct the program effectively. This depends upon the problem to be solved. For simple problems, right, we need not use any of these unconditional as well as conditional control statements. Now let us explore these conditional as well as unconditional control statements. First, let us explore this branch, conditional control statements. Conditional control statements are defined using these structured programming concepts: sequence, selection, iteration. Sequence, selection, iteration. These three are the important concepts in any structured programming. Sequence in the sense that the statements are executed in the sequential order: S1, S2, S3, etc. Sn. Having n statements in the order, sequential order. How about the flow of execution? Statement S1 gets executed first, then S2 is executed, then S3 is executed, etc. The nth statement is executed finally. That is the sequential execution of programming statements. Selection, this is used to select a particular block of statements upon the condition is true. For selection, we have some concepts. For example, first one is if statement. This is the simplest if statement. This takes the general form if condition, then statements 1, or we can write statement block 1, else we can write statements block 2. Then have a next statement, for example statement X. Here if, right, what is if defines the keyword. Condition, the condition which may be a relational expression or a logical expression. In C and C++, here any non-zero value, this is important. You need to make a note on this thing. Any non-zero value, this is taken as true. only the 0, this is taken as a false value. So clearly the condition is going to be tested, which may be a relational expression formed using the relational operators, or may be formed using the logical operators, or it may be a complex condition, complex expression. The expression is completely evaluated. If it results in a non-zero value, that is taken as a true block. The corresponding true block statements are this one. Statements block 1. Here we are assuming that statements block 1 represents the sequence of statements which are enclosed in the opening and closing curly brace. For example, S1, S2, etc. Sn. This defines the block of code. We have already seen the code block or block of code. Anything that is enclosed within the opening and closing curly braces defines the block of a code. So here, in the simplest form of if statement, the condition is tested first. If it results in a true value, that means if it results in any non-zero value, the true block statements, right? These are the true block statements. These statements are executed in the sequential order. In this case, control will never go to execute the false block statements, which are represented in the else block. So after the complete execution of the statements block 1, clearly the next statement to be executed is statement else. In case if the condition results in false, then control skips the true block statements. Then it goes to execute the false block statements here. Following the execution of the false block statements, the next statement to be executed is this one, statement X. So clearly, right, following the statement X, the sequential execution is taken place. This is said to be the selective statements because selectively we can execute the true block or a false block statements. In case if we have only one executable statement in the true block or false block, that executable statement, say S1, defined in this opening and closing curly brace, is equal to simply S1. That means we can omit this opening and closing curly braces. To execute more than one sequential statements as the part of a true block or a part of a false block, those statements must be enclosed within the opening and closing curly braces. This is the simplest logic of the if statement. If else right can be nested. For example, if condition 1, statement 1, semicolon, else if condition 2, statement 2, else if condition 3, statement 3, etc. Else if condition n, statement n, else say statement n plus 1. Here have, for example, statement x. In this syntax, if else if as a ladder, first condition 1 is tested. If the condition 1 is true, then statement 1 gets executed. Following this, The remaining conditions are skipped. Condition 2, condition 3, etc. Condition n. Clearly, the next sequential statement to be executed is statement X. This is the case when the condition 1 results in true. If condition 1 results in true, corresponding statement 1 or statement block 1 will get executed. In case if you do like to define statement 1 as a single statement, not necessarily included in the opening and closing curly braces. To have more than one sequential execution as a part of condition 1, that you must enclose the sequential statements within the opening and closing curly braces. In case if condition 1 results in false, then statement block 1 will not get executed. Else, if second condition is going to be tested. If condition 2 results in true, statement block 2 will get executed. Then remaining rate remaining conditions are skipped. Then sequentially, the next statement to be executed is statement X. Likewise, when condition 1 is false, condition 2 is false. Assuming that condition 3 is true, statement block 3 gets executed. Then subsequently, right? Subsequently, the remaining conditions are right not tested. Then control goes to execute statement X in the sequential order. So if a particular condition I results in true, corresponding statement block I will get executed. Then sequentially statement X is the next statement to be executed. In case condition 1 results in false, condition 2 is false, condition 3 results in false, up to the nth condition results in false. That means if we assume that all of these n conditions result in false, then ultimately the next statement to be executed is this one, statement n plus 1, right? This is the else block to be executed when all these conditions are false. After statement n plus 1, statement x will get executed in the sequential. This is the flow of if else if statements. We can also have nested if statements. For example, nested if statements. If condition 1, if condition 2, if condition 3, etc. If condition n, then say statement 1, else statement 2. So in this case, what happens? You need to check all the conditions. Condition 1, condition 2, condition 3, etc. Condition n. If all these conditions are true, because if C1, then we have returned if C2 condition, then if C3, etc. If Cn. If all these conditions are true, statement 1 will get executed. In case if any one condition results in false, statement 1 will not get executed, then statement 2 gets executed. Subsequently, we can assume statement X outside this nested if else block, so that after the execution of either statement 1 or statement 2, the next statement to be executed is statement X. This way, right, we can list if statements any number of times. So these are right the selective statements. Have any doubts in this? If else if nested if statements? Next one is the iteration. Iteration or repetition. When we want to execute the set of statements sequentially until the condition is satisfied or until some condition is going to meet, that stage we can use the iterative statements. In C language, we have the iterative statements for, while, do, while. First, let us see the execution of for. For takes this general form: for initialization, then conditional test, condition, control variable, modification for, then opening curly brace, set of statements for block, closing curly brace, then have the statement X. The execution of for first initializes this initialization part one time. So when the control enters into the for loop, initialization part is executed only once. Then condition is going to be tested. In case the condition results in true, the for block statements, which are defined within this opening and closing curly braces, are getting executed. After the complete execution of these for block statements, control goes to modify the variable, that you can say the control variable modification part. After modifying the control variable, then the condition is tested again. If the condition results in true, then control enters into the block of for. After this, control goes to execute the control variable modification part, then condition is tested again. As long as the condition results in true, the part of for block statements are executed, for loop statements are executed. Once the condition becomes false, control comes out of the for loop, then it executes the next statement sequentially following the closing curly brace of the for. That means statement X gets executed and a sequential execution is taken place. This is the logic of for loop. When we execute the set of statements repeatedly until the condition is satisfied or until some condition is going to be satisfied, right? Or as long as the condition remains true, what we have to do, we can use this block statement. For example, we can write for I is equal to 1, I less than or equal to 10, I plus plus, have a printf statement, printf I is equal to percentage d, comma I. Assuming that I is the control variable, right? I is initialized to 1 time. Then it takes the condition 1 less than or equal to 10, condition is true. So the value of I is printed, I is equal to 1. Then I is incremented by 1, variable I is incremented by 1, I becomes 2. Then it checks the condition if 2 is less than or equal to 10, condition is true. So I is equal to 2 gets printed upon the execution of this printf statement. Then I is incremented by 1, I becomes 3, 3 less than or equal to 10, I is equal to 3 is printed. Etc. When I reaches 9, Here 9 less than or equal to 10, so that we have I is equal to 9, the message is printed. Then I becomes a 10, 10 less than or equal to 10, condition is true. I is equal to 10 is printed. Then when I becomes 11, 11 less than or equal to 10, condition is false. So control comes out of the for loop. Right here we have only one executable statement. So we need not put the opening and closing curly braces. Even if we put open and closing curly braces, no problem. Then when the condition is false, control comes out of the for and it executes the next sequential statement starting from this place onwards. This is the execution of a for loop. The for loop can also be returned using the while loop. While takes this general form while condition set of statements. First, it checks the condition. If the condition results in true, control goes to execute the while block statements. These are while block statements. Then condition is going to be tested again. So as long as the condition results in true, the while block statements are executed. Once the condition becomes false, control comes out of while and it executes the next sequential statement following the closing curly brace, say statement X, in the sequential order. For example, the statements that we have returned here, for I is equal to 1, I less than or equal to 10, I plus plus. Printf I is equal to percentage d I can be returned as initialization part can be taken out of the while, say I is equal to 1. The condition to be tested is I less than or equal to 10. We can write while I less than or equal to 10. Then within the opening and closing curly braces, we can have multiple statements. Here let us have a single statement, say printf I is equal to percentage d I. Then here the next statement is say statement X. The flow of execution is I is equal to 1 sequential execution. Then condition is tested here I less than or equal to 10. The value of I is printed, say I is equal to 1. Next, control goes to check the condition I less than or equal to 10. Still I is 1, 1 less than or equal to 10. So infinite number of times while gets executed, we need to modify this part, right? Control variable modification part. So where can we do the control variable modification part? We can use it at the end of the while loop. So this I plus plus part is moved here after printing the value of I. Here we put I plus plus. So after printing I is equal to 1, then I gets incremented by 1, I becomes 2. It checks again the current I is less than or equal to 10, 2 less than or equal to 10, condition is true. So I is equal to 2 is printed. So this happens right up to when I is equal to 10. Then because of this I plus plus, current I 10 becomes 11. When I becomes 11, the condition to be tested is 11 less than or equal to 10. Condition is false. So control comes out of while block and it executes this statement X. This is the logic of a while execution. While this block, right, it can also be replaced using a do while block. Do while block.
Sir, in previous slide, I is equals to I plus plus, like that only we have to give no, sir.
Yeah, you can use I is equal to I plus 1. Here, I plus plus can be written as I is equal to I plus 1 plus I, both are same. We have already explored pre-increment, post-increment, and assignment operations with respect to the plus plus operator. Or even I is equal to I
Sir,
plus 1 can be written as I plus is equal to 1.
okay, sir.
Clear?
Sir, we have to write like I is equals to I plus plus, or only I plus plus is enough, sir. There in that place.
No, I is equal to I plus plus, that's different. I plus plus semicolon that increments the current value of I by 1, same as plus plus I. Or you can write I is equal to I plus 1. Otherwise, use the shorthand assignment operator plus is equal to as I plus is equal to 1. In case if you miss
Okay,
the
sir.
incrementation, decrementation part, no compile time error, right? But indefinitely or infinitely, I listen or equal to 10 is true in case if you are not incrementing the value of I by or not incrementing the value I. So at any stage, right, the entry condition into the while loop always true. So control will never come out of while. So carefully define the control variable modification part in part while and do while statements. Do while, this is similar to a while do while operation. Do set of statements block. Finally define while, then specify the condition. This while statement ends with a semicolon. Here the flow of execution is unconditionally control is entered into the do while block. So one time execution of do while statements are over before testing the condition. That means control enters into the do while block first. Part of do while statements are executed one time, then condition is tested. If the condition results in true, or as long as the condition remains true, the statements which are written in this opening and closing curly braces are executed. When the condition becomes false, control comes out of do while, it executes the next sequential statement following the while block. So this is similar to a while block operation, but this is said to be the entry controlled statement. Entry controlled for while are entry controlled statements. Because before entering into the opening and closing curly braces, condition is tested first. If the condition results in true, then only control enters into the block of for and while. That's what these are entry control statements. Where do while is said to be the exit control statement. Because after the execution of right one time do while statements, condition is tested. In case the condition is false, then control comes out of do while block. That's what this is said to be exit control statements. There is no such significant differences between these concepts for, while, and do while. Since we have right these concepts, this depends upon the user's point of view to choose any of these repetitive concepts, repetitive, iterative concepts for, while, and do while. Another one is a multi-branch statement. Multi-branch statement, that is a switch statement. This is also one kind of a selection statement. switch. The syntax is switch expression within this opening and closing curly braces. We can define case values. Case value 1 colon statement 1 break case value 2 statement 2, or we can have multiple statements break etc. Case value n statement n break. Then finally we can define a default block. Default some statement x. Then following the closing curly brace, we can have a statement y. This is a multi-branch statement, right? One kind of a selective construct. The expression is evaluated. The expression results in the integer value, or can be a character value 2, etc. value n. These are going to be matched, or these are the possible values of the expression when the expression gets evaluated. Assuming that the value of this expression is equal to value 1, because switch case default, these are the keywords. If the expression results in this value 1, the corresponding statements are executed here, statement 1, or have multiple statements. In case if you specify break, what happens? After this execution of statement block 1 or statement 1, remaining or subsequent statements will not get executed, then control goes to execute the statement y in the sequential order. In case the expression results in the value 2, only statement 2 will get executed. This break forces the control to come out of the switch block, then it executes the statement y. In case the expression results in value n, statement n will get executed. Given the break statement here, it forces the control to come out of switch so that statement y will get executed. In case if you are not given break, means after statement 1, statement 2, statement 3, statement n, right, all will get executed. In case the expression results in a value not equal to value 1, value 2, value 3, etc., value n, by default, the default statements will get executed. Then sequentially we can have the execution of statement y. The important thing is the expression results in the integer value. You cannot specify a floating point expression here. Another thing, value 1, value 2, etc., value n must be unique. You cannot define case 10 colon, case 10 colon, case 11 colon. That results in error because values must be unique and a distinct one. No duplicate values are to be defined in the case statements. This is said to be a multi-branch statement. How do we classify this multi-branch? Based on the expression? If the expression results in value 1, statement 1 will get executed. The expression results in value 2, statement 2 is executed. The expression results in a value n, statement n is executed. The expression results in a value which is not present in V1, V2, etc. Vn. Then default block will execute. Default statement will get executed. That's what this is to be a multi-branch statement. One kind of array, a selective constructor. For while and do while, which are coming under iterative or repetitive concepts. Even we can nest for loop. We can place a for loop right inside another for loop. That is to be a nested for statement. There the outer for right controls the inner for. Another one is unconditional control statements. Break, exit, return, go to, then continue. Break forces the control to come out of the for loop or while loop or to come out of switch statement. Upon the execution of break, right, it automatically the control exits from the inner loop. Exit right just to terminate the program execution so that the subsequent statements will never get executed. To terminate the program execution, you need to use the built-in function, right? Exit. Then a return right just transfers the control to the calling place. We can use return expression or a dummy return statement. Go to right as far as possible we need to avoid go to because go to requires the labeling statement, right? Go to some label colon that should be defined so that control is transferred to the specific label, but you cannot transfer the control from one function to another function. So as far as possible, right, try to avoid the use of go to in structured programming. Continue just continues the program execution. For example, in the for loop, for I is equal to 1, I less than or equal to 10, I plus plus. You can write if I is equal to 5, continue. Here you can have some statements. So when I is equal to 5, right, what happens? Continue skips the execution of the following statements. Then it transfers the control to the control variable modification upon. That is the usage of continue. Continue right continues the program execution so that the control is transferred to the control variable modification upon. Given the break right, for example, instead of a continue, break exits the control from the inner path. Return just transfers the control to the calling place. The usage of exit is right exit 1 or exit 0 right to be given as a function exit. So that stage the subsequent statements will never get executed. It automatically terminates the program execution. So you need to learn right these control statements, right? Conditional control statements, unconditional control statements, syntax, right? Execution. Then this forms the basis, right? Basic to solve the problem, right? That's what I have said. This is the most fundamental block in the structured programming: sequence, selection, and iteration. Have any doubts in this control statements? Otherwise, right now we solve the problems using these control statements.
Sir,
Yes,
sir, can I explain the continuous statement once more?
continuous statement. Okay. For example, right, I use a for loop for I is equal to 1, I less than or equal to 25, I plus plus. For example, here I am printing the value of I. Print I is equal to percentage d comma I. Next, I check one condition. If I is equal to 6, continue. Next, I use another statement, print end of for loop. Now, see the flow of execution. First, what happens? I is equal to 1, assuming that right, the variables are declared. I is equal to 1 gets executed one time. So, current I is 1. When current I is 1, checking the condition I less than or equal to 25, condition is true. If the condition results in true, the value of I is printed. I is equal to 1 is printed. Then it checks the sequential execution. If I is equal to 6, what is the current I? Current I is 1. 1 not equal to 6. The condition becomes false. That's all the flow of execution. If condition true means this will get executed. False, right? No false executable statement. So you can think of right this printf. Printf right end of for. So the condition becomes false, right? Then sequentially the statement will get executed. So you can see the message end of for. After printing I is equal to 1. Next what happens? I becomes to I plus plus because of I plus plus or plus plus I or I plus is equal to 1 or I is equal to I plus 1, whatever is there. Then I is equal to 2, 2 less than or equal to 25, condition is true, end of for will get executed. Then I is equal to 3, 3 less than or equal to 25, 3 is printed. Then I is not equal to 6, 3 is not equal to 6, so end of for gets printed. Then I is equal to 4, printed, end of for message is printed. I is equal to 5, printed, end of for message is printed. I becomes 6, 6 less than or equal to 25, condition is true. I is equal to 6 is printed. After printing I is equal to 6, it checks a condition if I is equal to 6. Since 6 is equal to 6, condition is true. What happens? What happens? This continue just continues its execution by skipping the subsequent statements following the continuous statement. That means whatever you have, in our example, we have only one printf statement. In case if you have right multiple executable statements following continue, upon this condition is true, unconditionally, hope you understand. Even we are checking the condition I is equal to 6, but continue is an unconditional statement. That means unconditionally control is transferred to continue its execution by skipping the following statements or continuous statement. So when I is equal to 6, condition is true, continue transfers the control to this block I plus plus. Next I becomes 7, 7 less than or equal to 25. Here what happens? Next I is equal to 7 is printed. If I is equal to 6, continue. Since current I is not equal to 6, you can see the message end of for. Likewise, I is equal to 8, 9, 10, etc. I is equal to 25. You can see the message end of for. Only when I becomes 6, because of this continue, the subsequent statements are right just skipped. So that for I is equal to 6, You cannot see the message. End of point. You can also write I is equal to 6, or you can write I mod 5 is equal to 0. If I mod 5 is equal to 0, continue. So depending upon the problem to be solved, you can devise a logic that may require the use of a continuous statement. Clear? Have any doubt?
Yes, sir. Yes, sir. Clear. Thank you,
Shall
sir.
we solve the problems? Okay, shall we solve the problems now? If you have any other doubts, you can ask now, right? Otherwise, I move on to solving the problems. Okay, please take the next problem. Print the add and even integers in 1 comma n. Assuming that n is the positive integer, n greater than 0, 1 comma n, where n greater than 0 is the integer. We need to print, right, the add and even integers in that interval, 1 comma n. How to solve the problem? First we include the header file, hash include stdio.h. Then define a main function into main, opening and closing curly braces. What is the input to this problem? N is one integer value. So let us define the variable int n and get the value of n first. Printf slash n, enter the integer n. Then have a scanf statement. Scanf percentage d ampersand n. We need to find, right, the add and even integers, right, and print them. So how do we check if n is add or even? Suppose n is 100, 1 comma 100. Assuming that in between 1 and 100, right, included 1 and 100, we need to find the add and even integers. How can we check if n is add or even?
If I mod 2 is equal to 0, then it is even.
Yeah, very good. If I mod 2 is equal to 0, then I is even. So let us use a for loop for we define the variable. For example, I, let us declare it later. I is equal to 1. I less than or equal to n. I plus plus. Or you can have a closed window mathematically. Okay, no problem. 1 and n are now included. I is equal to 1, I less than or equal to n, I plus plus. We are checking the condition for, right, as a part of for. For example, if I mod 2 is equal to 0, print the percentage d slash t comma I. We can use, right, previously, right, we can use one message. For example, print slash n even numbers. We can write the same code, edit, copy, shift insert, keyboard shortcut, printer slash n, add integers, I is equal to 1, I less than or equal to n, I plus plus, I mod 2, we can use, not equal to 0, then the values of integers are separated. Finally have a return 0 statement. The variable I needs to be declared. Save CP23. During the compilation time, we can see the error message. Undefined symbol I in constant main. The variable I is not yet declared. So let us declare I as integer type F9. Okay, running the code, control F9. I think previous programs, right, should be closed properly. 5 CP23, control F9, enter the integer n. I put n as 15. First, even numbers are printed 2, 4, 6, 8, etc. 15. Then add numbers are printed, odd numbers, right? Then 1, 3, 5, 7, etc. accordingly. Understand or not? Have any doubts in this example?
No, sir.
Okay. So let us see the next example. Take the next example. Uh, Find the value of n factorial. Find the value of n factorial. N greater than 0 or n greater than or equal to 0. This is an integer. So in this example, we do like to find the value of n factorial, right? The factorial of the positive integer or the integer when n is 0. We need to print its value. First include the header file hash include stdio.h. Then into main. Within the opening and closing curly braces, we need to define the statements. Already we have devised the algorithm to find the value of n factorial. So one input is retrieved, let it be n into n. Next, we need to get the input value, printf slash n, enter the value of n, enter the integer n greater than or equal to 0. This is the message to be given. We have a proper scanf statement, scanf percentage d ampersand n. Based on the value of n, we need to find the factorial value. So to find out the factorial, we can use the for loop. Simply for say I is equal to 1, I less than or equal to n, I plus plus. We can write the statement fact is equal to fact star I. Already we have devised the algorithm. We are printing the value of fact. Print n factorial is percentage d factorial is percentage d comma first percentage d n factorial is second percentage d. We need to use the variable fact, then have a return zero statement. Return zero. Declare the variables file save cp24. What needs to be declared? Variable I and the fact should be initialized to 1. Program has been compiled successfully. Control F9. Enter the value of n. For example, first I input a value 0. 0 factorial is 1, right? That is expected. So how do we test the program? Since the variable fact is initialized to 1. For loop starts with this initialization I is equal to 1. Check if I is less than or equal to n. Current I. What is the current I? 1. 1 less than or equal to n. What is n? 0. 1 less than or equal to 0, condition is false. So when 1 less than or equal to 0, condition is false, control comes out of the for block, it executes the statement printf percentage d is percentage d factorial is percentage d n comma fact. So we can see the message current n is 0, 0 factorial is 1. Understand? Suppose we give a value, control F9, enter the value of n, 5. 5 factorial is 120. Because here n which is not equal to 0, current fact is 1. So when I is equal to 1, fact is 1 into 1, 1. When I becomes 2, fact is 2 into 1, 2. When I becomes 3, fact is 2 into 3, 6. I becomes 4, 6 into 4, 24. I becomes 5, 24 into 5, 120. So that after the execution of this part, the value of fact is 120. So 5 factorial is 120. We have already traced right the logic of the algorithm, so I don't want to trace the same again. Have any doubts in this example?
Sir, how that printf statement works? So that before that return 0 statement.
Yeah. For is concerned for initialization. This is taken one time execution. Then I less than or equal to n. Suppose n is 5, 1 less than or equal to 5, condition is true. The part of for, right, only one statement. So we have not used opening and closing curly brace. Even if you use opening and closing curly brace, no problem. So when I is equal to 1, I less than or equal to n, condition is disturbed. The variable fact gets updated. Then I becomes 2. Condition 2 less than or equal to n. Condition is true. 2 less than or equal to 5. Fact is updated. When I becomes 3, 3 less than or equal to 5. The fact gets updated. Likewise, when I becomes 5, 5 less than or equal to 5. The fact becomes 120. Then I becomes 6. 6 less than or equal to 5. Condition is false. When the for loop condition is false, control comes out of the for loop. It executes the statement X following the for as the next executable sequential statement. So when the control comes to print this percentage D, carefully see how many percentage D's are here put. 2 percentage D's are put. So 2 variables or 2 expressions need to be put here. The first percentage D replaces the value of first variable n. The value of n is 5. So it seems 5. Then I used this exclamatory symbol, right, to have this factorial. So 5 factorial is this percentage d is replacing the value of variable this fact. So here you can have the value 120. Hence it seems 5 factorial is 120. Understand?
Yes, sir. Thank you.
Any other doubts? Any other doubts in this example? Okay, we move on to the next example. Yes, okay. File new. Given the positive integer n, given the positive n, find the or find its find the sum of its digits and reverse it. Suppose n is equal to 123, we are already seen the algorithm. We need to have the sum as 1 plus 2 plus 3. Sum is expected to have 6, and the reverse of n we expect to be a value of 321. We have devised the algorithm earlier and we have traced the algorithm. Now we are trying to implement the same right algorithm so that we are finding these two operations. How to find the sum of the digits of the given integer and to reverse the given integer n. I start with the code hash include stdio.h int main. Let us declare one variable int n and declare other variables right later. We need to input one value n printf slash n. Please enter the positive integer. Please enter the positive integer. Okay. This will be obtained through the scanf statement, scanf percentage d ampersand n. N is obtained right in the variable n. Then we need to find the sum of its digits. How to find the sum of its digits? What is the logic we have used here? We need to find the modulus 10 operation. The variable sum gets updated and the value of n should be divided by 10. So I write a while loop while n is greater than 0. Shall we have the operations as we defined the well-defined instructions in the algorithm? Sum is equal to sum plus n mod 10. Then having n is equal to n by 10. When the control comes out of while, we are printing the statement printf slash n sum of digits is percentage d comma sum. The variable sum needs to be initialized here. So initialize one variable sum here int n comma sum is equal to 0. Then we need to find the reverse of n. So I need to use another variable, say some x. After getting the value of n, I do want to store the value of n into the variable x. Otherwise, the value of n is lost because we have used n is equal to n by 10. I do want to use another loop, right? So that the second loop, right, reverses the value of x. That means the value of x is n, the value of x is reverted in this loop. So how do we write a statement while say I write n greater than 0 having one variable reverse r is equal to 0. What is the statement to be returned? R is equal to r into 10 plus n not n, right? This is x greater than 0. R is equal to r into 10 plus x mod 10. Please look into the algorithm that we have devised earlier. Then x needs to be updated. X is equal to x by 10. Print of slash n reverse is percentage d uh, reverse is held in the variable r. Then return 0. Closing curly braces. Declare the necessary variables r, right? Declared n x sum 0. R has also been set to 0. Let us check the code. File save C325 F9. Good, no compile time errors are reported. Control F9. Enter the positive integer 123. Sum of its digits 6. Reverse of the given integer is 321. Let us check another value. 1, 2, 3, 4. 1 plus 2 plus 3 plus 4. But then reverse is 4, 3, 2, 1. Control F9. 1, 0, 5, 2, 2, 5, 0, 1. 5 plus 2 plus 1, 8. Have any doubts in this program? I think no need to explain the logic again, since we have already constructed the flowchart, pseudocode, algorithm, and trace, modulus operations, everything, right, to find the sum of the digits and the reverse of the digits. Simply we have written a while loop here, then C language statements are written. Likewise in the reverse, right? One while loop along with C language implementation. The algorithm is simply converted to the C language. That's all. Have any doubts in this example?
No, sir. Clear, sir.
Okay. We move on to the next example. Please take the next example. File new. Write a program to print the multiplication table. You need to give a multiplication table for the integer n. Suppose n is equal to 12 is given. We need to print the multiplication table. What is 1 into 12? Suppose n is equal to 12. What needs to be printed? I write in the comments here. 1 into 12 is equal to 12. 2 into 12 is equal to 24. Up to, for example, 10 into 12
Sir,
is
it
equal
was,
to 120. Yes? Yes, tell me.
sir, 2 into 12, 24, sir.
Yeah, 1 minute. Yeah, 2 into 12. Okay, 24. Up to 10 minutes, right? 10 into 12 is equal to 120. And this will be great. So, what are the inputs? The value of n. N is equal to 12. So, 12th table. We need to control through the 12th table. For example, for I is equal to 1 to 10. So, seeing this, you can easily find 12, 12, 12, right? 12 is not changed. The value of n is not changed. Only what is changed 1, 2, 3, 4, etc. 10. So to control this 1, 2, 3, 4, etc. 10, what we have to do, we can use a for loop over the range of I. I is equal to 1 to 10. So devise a for loop for I is equal to 1 to 10. Write the value of I, then put star, write the value of n, then put is equal to, then find a value of I and n. 1 into 12, 12, 2 into 12, 24. So the values of I are 1, 2, 3, etc. 10. N is 12, right? A fixed one. After the right hand side, right, is equal to operator. The values are the product of current I and n. Hope you understand. So this can easily be solved using a for loop. For example, here we write to use a for loop hash include stdio.h, then write into main, opening and closing curly braces, have a statement return 0. The input to this problem is only the value of n. So I declare into n, a printf slash n, please enter the value of n. Please enter the value of n. So writing a scanner statement, scan percentage d, comma, ampersand n. Then to have this output, simply use a for loop. I start a for loop for the variable I needs to be declared. We declare later I is equal to 1. I less than or equal to how many rows we need. 1 into 12, 12, 2 into 12, 24, 10 into 12, 120. Here we have, right, 10 rows. In case if we like to have 25 rows or some R rows, you need to get another input R. In this example, I initialize the number of rows is 25. So I is equal to 1, I less than or equal to 25. I write a statement I plus plus. As a part of for, what we have to do, we need to write a printf statement to have the effect something x into y is equal to z. So clearly specify what is x, what is y, what is z. X into y is equal to z. X is the value of I. So I use a printf statement. Printf I is equal to, right, 1 into 12, 2 into 12, 10 into 12, 25 into 12. So 1, 2, 3, etc. 25. I replace the variable percentage d. Percentage d star as usual star. Then second one 12. What is 12? 12 is the value of n. Sorry, I use percentage d. Percentage d star percentage d. Then is equal to. We need to find the product of I and n in this case. Percentage d star percentage d is equal to percentage d, comma. First percentage d, we replace a variable I. This one. Left to right. Second percentage d, we use the value of variable n. I comma n comma. Third percentage d, this is simply the product of I and n. What happens I and n, right? I star n. This need not be, see, this need not be stored in some other variable, because here this is a percentage d. This percentage d is replaced by some variable or expression. So I write directly the expression I star n. And as this is possible, yes, it's true, it's valid. I star n is evaluated and the value is replaced to the third percentage d. That's all. Let us have one variable I int n comma I. Save the file and let us check the code. File is saved. CP26 F9. One error is there. What is the error? Call to undefined function print a t is missed. Okay. print F F2 control F9. Enter the value of n. N is 12. One thing, 1 into 12 is 12. Right. Second, 2 into 12 is 24 is printed. 3 into 12, 36 is printed. Finally, 25 into 12, 300 is printed. After one line, right, 1 into 12 is equal to 12. What we need to force the output to the new line. So what we have to do, for each value of I, we need to print the result in the new line. Shall we put simply one slash and here? Printf, each printf starts with the slash and character, so that the each printf is output in the new line. So control F9, enter the value of n, say 12. Now you can see the output. 1 into 12 is 12, 2 into 12 is 24, right, etc. 25 into 12 is 300. This is the multiplication table for n is equal to 12, having 25 rows. Have any doubts in this example? The same can be done with the help of while loop or do while loop. So whichever is desired, right, to the user, right, based on the user's point of view, right, you can use, or one can use the for loop, while loop, or do while loop. Have any doubts in this example? Have any doubts?
No, sir.
Okay, we move on to the next example. File save, okay. File new. Let us check if the given integer is prime or not. Check if the given integer is prime or not. Suppose n is the given integer, n is the given input. To check if the given integer is prime or not, we need to check the device source. We need to check the device source within the range 2, 3, 4, etc. n by 2. So within that range, we are checking if n has any device source. Hope you understand. Suppose n is equal to 100, what we have to do, we can check if 100, the number 100 has the divisors within the range for 2 to n by 2. For 2 to n by 2 means what happens 2 to 50. Because after n by 2, after 50, there can be no divisor for any n. So we are checking only the divisors within that range 2, 3, 4, etc. n by 2. That means further check if n is divisible by 2, n is divisible by 3, n is divisible by 4, etc. n is divisible by n by 2. At any stage, if you find any divisors or any divisor within this range 2 to n by 2, then you need not check if n has some additional divisor. Ultimately, you can say the integer n is a composite number because it has some or it has at least one divisor within the range 2 to n by 2. In case if it continues, right, 2 to n by 2, all of its divisors are, all of its range, right, now integers are not the divisors, ultimately great, the given integer n has divisors, right, 1 and n. That means the given integer n is a prime number. Hope you understand. For example, here I take one example. Suppose n is equal to 63, 2, 3, etc. 63 by 2, 63 by 2 up to 31, 2, 3, etc. 31. We are checking if n has any divisors within this range 2 to 31. So when n has any divisor within this range 2 to 31, then if you find the first divisor, there itself terminate the process. So here n is equal to 63. First finding 63 mod 2. This is 63. How to check? 63 mod 2. This is not equal to 0. 63 mod 3 not equal to 0. This is, sorry, 63, sorry, mod 3 not equal to 0. 63 mod 4 not equal to 0. 63 mod 5 not equal to 0. 63 mod 6 not equal to 0. 63 mod 7, what happens? What is 63 mod 7? 63 mod 7.
0.
0, sir.
0. Since this is 0, we have the first divisor for n is equal to 63 in between 2 and 31. In an order we are checking for 2 to n by 2. So I need not check if 63 has some divisors within the range, right, or continuing, right, 8, 9, 10, etc. 31. So here itself, right, I need to conclude, right, how I have to conclude. I just write, I need to print the result, right, the given integer is not a prime number, a given number is not prime. So that the subsequent operations are to be skipped or subsequent operations are not necessary, unnecessary. So devise a logic accordingly, right, to conclude the result once you find the first divisor itself. So let us solve the problem. Hash include stdio.h. Yes,
63 mod 3 is also equal to 0.
yeah, 63 mod 3 is equal to 0, right? What happened? 63 mod 3, 21. So 63 mod 3 is equal to 0, right? That's all. You need not continue the remaining operations. So there is no need to check the divisors 4, 5, 6, 7, 8, 9, etc. So let us construct the code hash include stdio.h. Writing into my here declare one variable int n printf slash n, enter the value of n, then write a scanf statement, scanf percentage d, comma ampersand n, control through a for loop for I am missing the initialization. Okay, let us have one variable j. J is equal to 2. J less than or equal to n by 2. J plus plus. Checking if n mod j is equal to 0. That means when j is a divisor of n, if n mod j is equal to 0, then what we have to do, we need to tell the given integer is printf. I write a printf slash n percentage d is not prime. So when, for example, 63 mod 3 is 0, so we need not check the remaining integers of 4, 5, 6, etc. up to n by 2. So that itself we can terminate the process. Right? To terminate a process, call a function, exit function, right? You can use exit 1 or exit 0, right? To terminate the process. In case for j is equal to 2 to n by 2, at any stage if n mod j is not equal to 0, when j plus plus, right? When the condition j less than or equal to n by 2, control comes out of the for. Here we have the message printf slash n percentage d is prime. Then finally we need to have statement return 0. Not needs to be declared int n, comma j should be declared. Let us save the file, what is the name file, cp27, compiling the code, control F9, error is 1, the error is right in the exit function. The exit function is a built-in function which is defined in the header file stdlib.h, or you can include the header file process.h hash include process.h, otherwise include the header file standard library stdlib.h. Because here exit to terminate a process, right? The operating system functions are defined in the header file process.h. Include that header file. Control F9, enter the value of n. 63. 63 is not prime, that is expected. Percentage d is not prime, comma, the value of n should be replaced here. Percentage d is prime, comma, the value of n is replaced. Control F9, enter the value of n. 63. 63 is not prime. That means 63 is composite. Control F9, enter the value of n. 247. 247 is not prime. Control F9. 251. 251 is prime. Understand? Have any doubts in this example?
Sir,
Yes.
what is the use of exit function, sir?
Yeah, very good. The use of exit function is here, as we seen earlier. Once 63 mod 3 becomes 0, what happens? The subsequent operations should not be executed. So these are the subsequent operations. You need not continue the remaining operations since current divisor J is equal to current divisor is J is equal to 3. 63 mod 3, right? 21. Remainder is 0. So there is no need to check it. 63 has the divisors in the range 4, 5, 6, etc. 31. So we are not continuing the remaining operations. J is equal to 4. Checking if J is a divisor of 63, N. Unnecessary. Checking if 5 is a divisor of J. Sorry, 5 is a divisor of N. Unnecessary. Checking if 31 is a divisor of N. Unnecessary. Since there is a that we have found right one divisor as J is equal to 3. This is enough right to conclude the given number is not prime or the given number is a composite. So in this stage, subsequent operations are completely not necessary. So to avoid that, we can terminate the process. Normally in the algorithm representation, right, we have returned, right, finally the statement stop, then end. That end terminates the program execution. Here, exit, what happens? It terminates the program execution so that J will not get incremented further. So after the message percentage D is not prime, we need not continue the execution for the subsequent values of J. So next J will not be incremented by 1. J will not be checked, right? If it is less than or equal to n by 2, then it will not check n mod J is equal to 0. So simply understand, we have terminated the program execution. Means statements are executed further. Program is entered, that's all. Clear?
Sir,
Yes,
what about
Here,
9, sir?
what about
9, number 9. Because it is not divisible by 2, but it is not a prime number, no, sir.
9? Yeah, 9 is not a prime number. Control 1 minute. Control F9. Enter the value of n. 9. 9 is not prime. How the logic is executed? We have input the value of n as 9. N is equal to 9. We are checking the divisors for n within this range. J is equal to 2, 3, 4, etc. n by 2. That means 2, 3, 4, etc. 9 by 2. 9 by 2, what happens? 4 into 2, 8. So checking the value of J as 2, 3, 4. When J is equal to 2, 9 mod 2 is not equal to 0. When J is equal to 3, 9 mod 3 is equal to 0. It seems 3 is a factor or divisor of 9. So we are terminating the process without checking if 4 is actually a divisor of 9. Understand?
Yes, sir.
Any other doubts?
Sir, can you explain any program using do while loop?
Okay, do while loop. 1 minute. Okay, take the next example. Find the value of 1 square plus 2 square plus, or take 1 square plus 3 square plus 5 square plus etc. up to some j terms, up to first j terms, using do while statement or do while loop. In case if the question is right based on a specific loop, right, you need to or you must use right the specific looping construct. So in this example, right, 1 square plus 3 square plus 5 square plus etc. up to first j term. Suppose j is equal to 3 means first 3 terms in this sequence, right? 1 square plus 3 square plus 5 square. When j is equal to 5, first 5 terms 1 square plus 3 square plus 5 square plus 7 square plus 9 square is expected. We need to solve the problem using a do while loop. First include a header file hash include stdio.h. The problem can be easily solved because 1 square plus 3 square plus 5 square, right? First to j terms, so we can initialize, right? Or we can fix set the number of terms required, right? So checking if j terms are reached, first j terms are reached, right? We can terminate the process or we can stop the process. See how to solve this. Int main have a statement return to 0. What is the input to this problem? What is the input to this problem? When we write 1 square plus s is equal to 1 square plus 3 square plus 5 square plus etc. up to first to j terms, j is equal to 1 means s is equal to 1 square is expected. J is equal to 2 means s is equal to first to 2 terms. Understand? We have devised the problem in such a way that having first j terms, we need to evaluate like this. J is equal to 3 means s is equal to 1 square plus 3 square plus 5 square. So what is the input to this problem? 1 square, 3 square, 5 square, 7 square, etc. Right? That is the common one. Only the number of terms need to be defined. So we need to input the value of j. For example, int j. What is j? J defines the number of terms. Printf hash n. Enter number of terms to be evaluated. Number of terms to be evaluated. Scanf percentage d ampersand scanf percentage d ampersand j. Now we need to get the value of n. The value of j. The j is obtained in the variable, right? Scanf percentage d ampersand j. Sum, right? To have a sum, we need to use one variable. Say yes, the result needs to be updated in yes and initialize the value of s to 0. Because every stage, right, it seems s is equal to 1 square plus 3 square plus 5 square plus etc. After finding 1 square, right, then s needs to be updated as s is equal to s plus 3 square, then s is equal to s plus 5 square. As we fixed the problem using a do while loop, we need to find a count, right, the number of terms. The total number of terms to be evaluated is j. So we can use one count here. I use a variable count. Do while loop, right? So do up to j terms, right? At least the value of j should be 1. J is greater than or equal to 1. So here I use the statement do, then here I check the condition while count is less than or equal to the value of j. Let us check and modify, right? First, have the statement s is equal to current s plus, we need to find, right, 1 square, 3 square plus 5 square. So have another variable, for example, I, int I comma j comma, what needs to be set I can be set initially I is equal to 1. So shall we write s is equal to s plus I star I, not I star 1. If you write s is equal to s plus I star I, current s is 0, 1 into 1, 1. So 1 square is computed, while count less than or equal to j. Count is 1 less than or equal to j. Suppose j is 1 means 1 less than or equal to 1 condition is true. Again control enters into the do while part. So it tries to find the second thing. So if we stop here, count less than j. Now what happens? Count is, what is count? Count needs to be set to 1. Count initially set to 1. Count is equal to 1. Then s is equal to s plus I star I. Count, let us increment count by 1. Count plus plus. Now count becomes 2. Or 2 less than j. 2 less than j, right? What happens? What is the value of j? For example, j is 1. 2 less than 1. Condition is false. So to have count as 0, count plus plus. Now after the execution of s is equal to s plus I star I, count becomes 1. That means first time is evaluated. Now count, right? 1 less than j, 1 less than j, suppose 1. Condition is false. Control comes out of y. Suppose j is 2. Initially count is 0. S plus I star I. 1 into 1, right? 1 square is evaluated. Next we need to have count, right? Count as 1. Count is 1. 1 less than j, 1 less than 2, condition is true. Next s is equal to s plus I star I. I needs to be incremented by 2. So I write here I is equal to I plus 2. Then only we have s plus I into I means 3 into 3. Suppose j is 2. Initially s is 1 square. Count is 1. Then I becomes 3. Count is 1. 1 less than j. J is 2. 1 less than 2, condition is true. Then I becomes 3. So next stage s plus I into I, that means 1 square plus 3 square is evaluated. Count becomes 2. 2 less than, right, 2, condition is false. It won't include 5 square. So let us print the value of count here. Sorry, let us print the value of s here. Print percentage d or sum is percentage d, comma, sum is stored in the variable yes. Let us check the code. File, save. What is the file name? Next number file, cp28. cp28. Check if all the variables are declared. I, j, count. Okay, F2, F9, control F9. Enter the number of times to be evaluated. If I put 1, sum is 1. It's correct. Control F9, enter the number of terms to be evaluated. 2. Sum is 10. 1 square plus 3 square, right? 9 plus 1 at 10. Then a sum is 3. Sorry, enter the number of times to be evaluated. J is 3. 5 into 5, 25. 25 plus 10, right? Already 35. Suppose control F9. Number of terms to be evaluated 4. 3 square plus 5 square plus 7 square, right? 7 square 49. 49 plus previously 35, right? We have the quantity 82. So this logic finds the sum of first j terms in this sequence 1 square plus 3 square plus 5 square plus etc. That's all, right? First j terms are included in this sequence. Have any doubt in this example? The usage of do while loop is introduced. We can also introduce, right, a while do or for, whichever is right preferable, right? You can use. But in the question, right, a specific thing is mentioned. You need to solve it using that accordingly. Any doubt in this example? Then you try to solve these exercises. I type the problem here itself. Evaluate S is equal to 1 plus 2 plus 3 plus etc. up to n. The sum of first n natural numbers. Don't evaluate it directly as n into n plus 1 by 2. We can solve the problem using for, while, do while. Or sometimes the question is right solved right by using all the three for, while, do while. Separately right find the value of s using for. Then apply while to find the value of s. Apply do while to find the value of s. Then try to find this evaluation s is equal to 1 minus 2 plus 3 minus 4 etc. up to first n terms. So in this case, right, 1 minus 2 plus 3 minus 4. Initial value of n is 1. Then the next n is right minus 2. Then next n right plus 3 minus 4. Sign is alternating 1. So it seems 1 plus 3 plus 5 plus 7. Sum of odd numbers and minus 2 minus 4 minus 6. Right, the negative sum of even numbers. You try to find the logic accordingly so that you can find 1 minus 2 plus 3 minus 4. Suppose n is equal to 3 is given. What is the meaning? First 3 terms need to be evaluated. 1 minus 2 plus 3. This is the first 3 terms. So you can find this evaluation as 1 minus 2 minus 1 plus 3s or 2. Suppose first 4 terms are given. You need to evaluate only this highlighted expression. 1 minus 2 plus 3 minus 4. Likewise, right, n terms are given, right? You need to write 1 minus 2 plus 3 minus 4, etc. Then the last term is minus f8. So this way, you need to devise the logic here. So to bring the alternate plus minus, here you can introduce one variable sign. For example, sign. Sign is initially set to 1. So that here when you find the value of s plus I means I is multiplied by sign is 1. To update the next value of s is equal to s plus I. Before that, the variable sign needs to be negated. Sign is equal to minus sign. So after this, we can introduce sign is equal to minus sign. So when the next evaluation is taken, s is equal to s plus I into sign. Since the sign is -1, it forms this expression 1 minus 2. Next stage, currently sign is -1. Next, if you negate sign right inside the loop, so sign becomes positive. So that the alternating signs plus minus etc. that can easily be brought inside the looping statement. Understand?
Yes, sir.
Okay, likewise, right, you can solve the problems that we have solved earlier, right, using a flowchart algorithmic constructor. Say the Fibonacci numbers, finding the nth Fibonacci number, and finding the GCD of two integers using while loop or the normal statements that can be right solved. And go through right some other examples right that we have solved right to check the given integer is odd or even. Then you can find right the given integer or given year is leap or not, or to find a count on how many numbers are divisible within that interval. Suppose if you give 1 comma 1000, you need to find out how many divisors are there, right? For example, based on the value of g. And you can use the a for loop or while loop or do while loop accordingly based on the logic rate. You can use any of these things along with the conditional as well as unconditional control statements. Have any other doubts? Have any other doubts?
No, sir.
Okay, I post the materials and the video right after some time. So please go through the session and solve the problems. As I said earlier, you need to create one folder right in your Gmail and update right all the exercises right in that folder so that I can check it easily from your shared folder. Okay, we will discuss in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.